And our tutorial today, we are going to look at a question that is coming from Seco Properties. And the question reads, in the diagram below, A, B, C, and D are points on the circumference of a circle. TCM and MDE are tangents to the circle at C and D respectively. Then given that AB is equal to AD, then CBD is 47 degrees and BDC is 23 degrees. Calculate angle BCT. Now, this angle BCT, okay, it is an alternate segment with angle BDC. So, we are going to say that angle BCT is equal to angle BDC. Okay, why these are alternate segments. Okay, so therefore we're going to say that BCT is equal to 23 degrees. Okay, then the next angle, which is Roman numeral 2, we are told to find angle BAD. Now, angle BAD plus angle BCD, it's going to give us 180, meaning the sum, okay, of two opposite interior angles of a cyclic quadrilateral adds up to 180 degrees. So meaning when you add your BAD, okay, plus the BCD, supposed to give us 180. But in this case, we don't have the BCD. So how do we find BCD? We'll therefore say that BCD plus 47 degrees, then plus 23 degrees, that should give us 180. Okay, angles in a triangle add up to 180 degrees. So BCD plus 47 degrees plus 23 degrees, that's going to give us 70 degrees, being equal to 180. So when the 70 degrees crosses the equal sign, we're going to say that BCD is equal to 180 degrees minus the 70 degrees. So BCD will be equal to 110 degrees. Now, when BCD is equals to 110 degrees, therefore, we can say that BAD is equal to 180 degrees minus 110 degrees. Because the principle is that when you add BAD plus BCD, is supposed to give us 180. Therefore, BAD will be equal to 70 degrees. Okay. You go to the next one, which is ABD. Okay, the angle here. Okay. Now, if you look at triangle ABD, you discover that AB is equal to AD. Okay, making the angle at B and the angle at D to be equal. So this is an isosceles triangle where two angles are equal. Then knowing that we have got the angle here which is 70, so how do we find ABD? Therefore, we shall say that ABD is equal to the sum of angles in the triangle add up to 180. So I'm going to say 180 degrees minus 70, then you divide by 2 because two angles are equal. So 180 minus 70, it's going to give us 110. So if you divide, we're going to say that angle ABD is equal to 55 degrees. Okay, like that. Then we can look at the last one, which is DMV. Now, there is a property that talks about equal tangents. Okay, so as we can see that TCM and MDE, these are tangents. So the distance from C to M is equal to the distance from M to D. So meaning this and this, they are equal. Now, if these two are equal, okay, we can also look at the other property that we talked about in Roman numeral 1, which is alternate segment. Remember, we said the angle here is 23 because this angle here and the angle at D, the alternate segment. It's the same with the angle at B, which is 47 here. It is also equal to this angle here. Okay, they are also alternate segment. So if this is 47, that makes this also to be 47 because the two angles should be equal due to the fact that the line CM is equal to the line MD. So if these two angles are equal, it becomes very easy for us to find DMC. How do we find DMC? We shall say angles in the triangle add up to 180. So DMC plus 47 degrees plus again 47 degrees, that's going to be 180 degrees. So DMC plus 47 plus 47, that's going to give us 94 degrees being equal to 180. So when the 94 crosses the equal sign, we are going to say that DMC is equal to 180 degrees minus 94 degrees. So angle DMC will be equal to 86 degrees. Okay, so that is it for today. We're going to meet next time as we'll be looking at another question.